So these are your answers for the Unit 2 study guide. For number 1, making a chart comparing charge, location, and masses of the protons, neutrons, and electrons. We've done that several times. So this is information that you have to know. What I'm seeing is that a lot of people are getting electrons and neutrons, that information reversed. So make sure that you understand the difference between the two. For number 2, draw and label the two regions of an atom. For that one, just do a simple drawing like the one that I put in your notes video. In the center, you have the nucleus with the electron cloud around the outside. So, simple drawing of an atom with its two regions. And then for number 3, it says that up here you drew the two regions of an atom and compare and contrast the size of each region and decide whether your drawing represents them accurately. In the video, I talked about how if the nucleus of an atom were the size of a dime, the electron cloud of that atom would be the size of a football field. So in comparison, the nucleus is extremely tiny compared to the electron cloud. Now, I tried to portray that in this drawing, but in reality, in a drawing, you can't really be accurate. So just keep that in mind because of the enormous size difference. And then for number 4, the number of electrons is equal to the number of protons in a neutral atom, but in an ion, electrons have been lost or gained, causing the atom to be charged. So ions are a charged atom. The atomic number is equal to the number of protons. And in order to calculate the number of neutrons, you have to take mass number minus atomic number, because mass number is the total of protons and neutrons in an atom. So if I subtract the atomic number, which is number of protons, it's going to give me neutrons. And then tell the difference between mass number and atomic mass. Well, as I just said, mass number is protons plus neutrons in an atom. It's always a whole number because you can't have 0.2 of a proton or 0.2 of a neutron. And I put this little asterisk right here because it cannot be found on the periodic table. Mass number has to be either calculated by adding protons and neutrons or given. While the atomic mass is the average mass of all known isotopes of that element, and that is what is found on the periodic table. For number 8, what is an isotope? That definition should be in your notes, so that should have been easy points. But they are atoms of the same element that have different numbers of neutrons. So, number 9 says isotopes of the same element have different masses, but their atomic number stays the same. Why? This is why. If they are the same element, they have to have the same atomic number. Otherwise, if their atomic number changes, they change into a different element. So that is why. Number 10, do isotopes of an atom have different physical or chemical properties than the original atom? No, they don't, because they are the same element. And if you're the same element, you have the same properties. And then what is the most common or most abundant isotope of rubidium, which is atomic number 37, and use isotope notation to write your answer? Well, in the video, I talked about how to find most common isotope. So if you look at the periodic table, if I can get it in focus, it said rubidium is number 37, and down here is our average atomic mass, which is a weighted average, and it is weighted towards the most common isotope. So the most abundant isotope is going to be what the average atomic mass is closest to. So if I round the average atomic mass to the nearest whole number, that's going to give me the most common isotope. So to put it in isotope notation, I have to write the symbol, a dash, and then the mass number of the isotope, which would be 85. For number 12, identifying everything in the periodic table square, I've done that. I also wrote down what they tell me. So the atomic number tells me number of protons. The average atomic mass can help me to find the most common isotope, which I just showed you on number 11. Number 13, what is an atom? Obviously that definition is right there in your notes. All you have to do is copy it down. It's the smallest particle of an element that retains the properties of that element. So that means if one single atom of iron is present, it is going to have all the properties of iron. And then number 14 was calculating all of these aspects of these atoms. So I'm going to go through a couple examples of these to help you understand how I do it. So for this one, I'm given the atomic symbol and the neutrons. So what I would do, the atomic symbol helps me to find it on the periodic table. So once I do that, here's my atom right here. This number right here gives me number of protons. So I'm going to go ahead and add that. Atomic number is the number of protons. And then in an atom, protons are equal to electrons, so that's going to be the same. Then the mass number, as I said earlier, protons plus neutrons. So 5 plus 6 give me 11, while the atomic mass has to be found on the periodic table. So I'm going to take a look back at that. And the atomic mass is here, so I'm going to add that in as 10.81. As a second example, we're given an atomic number, so that tells me where to look on the periodic table. It goes in number order. So atomic number 11 is here, which tells me that it's sodium. So I'm going to fill that in. And atomic number is equal to protons, which is equal to electrons in a neutral atom. Tells me that the mass number is 24. So if I take to figure out neutrons, I'm going to have to take the mass number, which includes protons and neutrons, and subtract off those protons so I can solve for the neutrons. So 24 minus 11 gives me the 13. And my atomic mass from the periodic table is 22.990. So then here are the rest of those answers, so you can check them. And then for what is an ion, obviously that definition is in your notes, but that is an atom that has gained a positive or negative charge due to the loss or gain of electrons. So a little bit of practice with these ions. Here I have sulfur, which is 2-, and that 2- is what's important to figure out the protons and electrons in an ion. Remember that protons are positive and electrons are negative. So if my ion is negative, I have to have more of these to make the charge happen. I cannot change this number because loss or gain of electrons only is what causes the charge. So that is why I have 16 protons. I looked on the periodic table to find sulfur, which is here. It tells me 16 protons, and since I have a charge of 2- and electrons are negative, that means I have 2 more of them to give me my overall charge. So one more example, a positive ion. If I look up potassium on the periodic table, it is number 19, so it has 19 protons, and this charge right here is a 1+, which if it's a 1, I do not actually have to write it, it's redundant, because that positive there tells me there's one of them. And if it's a positive, that means I have more protons than I do electrons. So this would have 18 electrons also. So this ion gained electrons to become negative. This ion lost an electron to become positive. So we can take a look at the rest of those. And then to draw an atom of nitrogen 15, this is isotope notation, which means that that is a mass number. So if I look at nitrogen on the periodic table, it has 7 protons, and it's an atom, so it's neutral. So electrons are 7. And then to get my neutrons, I'm going to have to take my mass number minus protons to give me my neutrons. And so if I draw an atom, inside my nucleus is where I'm going to find the protons and neutrons. So there are 7 protons in there, 7 positives, and then there are 8 neutrons in there. And then out here in the electron cloud, there are 7 electrons. Now that's as good of a drawing as I need for right now. As we progress in the class, you'll be able to make far more accurate drawings. But for now, this is fine. You're showing me you can calculate the numbers and you know where they go in the atom. And then columns of the periodic table are known as groups or families. Rows on the periodic table are periods. And then for number 20, labeling the 3 categories of elements on the periodic table. I went ahead and did that with some color here. And then the bolded elements were this section right here. Those are the transition metals. And then for number 22, the bolded elements below were meant to be this section right here, but somehow that escaped my notice when I checked this. So that should be the bolded section, which means that they are the inner transition metals. And then for number 23, at least 3 properties of metals, they were in your notes. Any of those are fine. Labeling all of these things on this periodic table up here. Alkaline earth metals are group 2. Alkali metals are group 1. Inner transition metals, obviously, right there. Actinide series is the bottom. Lanthanide series is the top of the inner transition. And then for 25, through identifying properties of nonmetals, those were in your notes. The group number of the halogen family is 17. And then the group number of the noble gas family is 18. For number 28, why do we use the name noble gases and what makes this group different from all the others? I talked about in the section 3 video why we call them the noble gases. So if you do not know that answer, you need to go back and listen. What makes them different is that they are completely unreactive. They do not do much of anything. And then number 29, where can I find metalloids on the periodic table and what kinds of properties do they have? I just showed you on the previous page where the metalloids are. They're between the metals and nonmetals. And their properties are kind of a mix of metals and nonmetals. So the example that I used before was if metals are good conductors and nonmetals are bad ones, a metalloid is an okay conductor. Kind of has an in-between property like that. And then on this periodic table, we're identifying where the representative elements are and the transition metals. So I put the representative elements in a color, and everything else is transition metal. And then number 31, why are the inner transition metals given that name? I talked about that in the video, so if you do not know, you need to go back and listen to the section 3 video. And then the properties of metalloids, we talked about it earlier, so I don't know why I put that twice. I apologize. And then number 33 is your bonus point opportunity. So I suggest you use your time wisely and get some of those because those opportunities don't come along that often. So make sure that you study. Test is on Friday. Good luck.